Hello precalc students, this video note is example 4 of section 4.3. The direction is find complex zeros. So complex zeros meaning now we can have imaginary zeros, right? And real zeros as well, okay? So that means every single solution that you can find. So first, it has 4 terms. So x to the third plus 13x squared plus 57x plus 85. What you want to do is you want to see if it's factorable. Okay, so 57 is not divisible by 2, and to see if 57 is divisible by 3, you add up the digits. Okay, so that's 12. Since 12 is divisible by 3, 57 is divisible by 3. 8 plus 5, that's 13. 13 is not divisible by 3, so therefore 85 is not divisible by 3. Next, what you want to see is divisible by 5 maybe, okay? 85 is, because it ends in 5, but 57 isn't. So, but how about 13? Because what I see is these two right here, right? Let's set equal to 0 first. So to solve the zeros, we set it equals to 0, hence 0, solve for 0, find the zeros. So it's 4 terms, so you want to factor it by grouping. Okay, I want to see if I can take out an x squared here, because that's what they both have in common, and then I end up with x plus 13. So let's see if it's divisible by 13 perhaps. Okay, let me go and find my calculator. I'm not really good with using the calculator on here, but let me just go and grab my graphing calculator really quickly. Okay, graphing calculator, where are you? All right, let's go back to here. So let's see, it's 57, does it go into 13? Nope, it does not go into 13. 57 goes into 319 times, okay, but 85 doesn't go into it. So right now, this right here is not factorable, not factorable. So what our next step that we talk about in class is that the potential zero, the p divided by q, would take too long for us to find the 1 0. So I allow you to cheat. Remember this? So I'm going to find my decimals since you can't see the graphing calculator. Okay, so let me go and find decimals. Where is decimals? Here, Chromebook. Okay, so here we go. So what we're going to do is we are going to enter in the polynomial. And let me minimize this to see what the polynomial is, okay? Come on. It's giving me a little bit of a technological. All right, minimize this. Okay, so what is our polynomial? Move it over here. It's x to the third. So x to the third. Plus 13x squared plus 13x squared plus 57x and plus 85. Okay, so in previous notes, we are able to use a calculator and cheat a little bit. So according to my decimals, my cheating allows me to see that x location is -5. So if you can see, I can zoom it out as far as I can. It doesn't loop back down. So it looks like there's only one real zero. The thing is that when you find the real zero, imaginary won't cross the x-intercept. That's why they're imaginary, right? Think of it as kind of in your head, but the real ones would definitely show on the x-axis. So by cheating, we found one real zero. Okay, so when I say cheating, I really mean like using the calculator. Okay, so using the calculator, we found one real zero at x equals -5. Now, what do we do with this? We can now use synthetic. Okay, so the synthetic box goes here. So -5 goes here. X to the third, x squared, x 85. I don't have any missing terms, so I'm going to write down all of the leading coefficient. I'm going to drop this one straight down, so that's going to be 1. -5 times 1 is going to be -5. 13, take away 5 is going to be 8. Multiply, -40 is going to be +17. And I'm going to try to multiply 5 times negative 17 is now negative 85. We do expect the remainder to be 0, okay? So because we started out with x to the third and we divided by one real 0, the real 0 is x equals negative 5. What does that mean? That means a factor is x plus 5, okay? So when you have x to the third divided by 1x, now the highest power is just x squared plus 8x plus 17 equals 0. So I'm going to try to write that a little bit nicer down here. So x squared plus 8x plus 17 equals 0. 17 is a prime number, so right now the only possible factors are 1 and 17, and when I add or subtract those, that's not going to give me 8. So this is not factorable, which I now need to use a quadratic formula. So x equals negative 8 plus or minus b squared, which is 8 squared, minus 4 times a, which is 1, times 17, which is c, all over 2 times a. So this is going to give me negative 8 plus or minus 64, okay? Now it's going to be a minus. 4 times 17 is going to give us a nice number of 68, all over 2. So x equals negative 8 plus or minus negative 4. Now, before this unit, we would say that, hey, this is not a real number, so we cross it out, and we would only box up x equals to negative 5 as a one real solution. But we are under complex, so under complex, to solve this, what does that really mean? Square root of negative 4, think of it as square root of positive 4 times square root of negative 1. Okay, yes, that's how you separate the negative numbers. Square root of positive 4 is now 2, so that's okay to have. Oops, negative 8, sorry. So bring down the negative 8 still, that hasn't changed, so this is going to be a 2. Well, remember, square root of negative 1 is always I, so divide that by 2. You need to factor out, we can factor out positive 2, okay, so we can reduce. So factor out positive 2, we now have a negative 4 plus or minus I all over 2. So these two are going to cancel. So now you're left with a 2 imaginary solution. One's a positive, okay, and one is a negative. So let's write all of our solutions together in one box, okay? The real answers are x, we cheated, we got negative 5 from the calculator, and we solved by hand. We have a negative 4 plus or minus I are the remaining 2 imaginary ones. So we have 3 complex all together. And that should match the degree, okay? If you have a degree of 3, that means you should have 3 total answers, okay? Now let's move on to B. If this is difficult, keep in mind that you should go back and watch this another time, possibly 2 more times, just so that way you have a better understanding. B, find the complex 0. That means I need to find everything, imaginary and real. You have a degree of 3, that means I should have a total of 3 answers, okay? So let's see if I can factor anything here. You never know. So I'm going to factor by grouping. We have 4 terms. It's always a good idea to start with factor by grouping. So the first 2 terms, all I see is they have x squared in common, okay? So if I take out x squared, I now have 3x minus 7. The other 2, I don't know what else they have in common, but I can definitely try a 4. 12 divided by 4 is 3x. 28 divided by 4 is minus 7. Oh my, this is awesome, right? I don't even have to use my calculator for cheating. So these 2 are both in common. You factor that out, okay? So 3x minus 7, that's what they have in common. Factor it out. Now you're left with an x squared plus 4. All of these are going to equal to 0 because you're solving for 0. Take each factor, set it equals to 0. I love it when it's factorable, or I love it when I can get down to an x squared, right? Because if it's not factorable, I can easily use my quadratic formula. So move the 7 to the right, so 3x equals 7. X equals 7 divided by 3. Ooh, nice. That's one real answer. So x squared equals negative 4. Well, this one, I definitely will expect it to be some imaginary because look, I am taking a square root, and when I take a square root, it's a square root of negative 4. Break square root of negative 4 into square root of 4 times square root of a negative 1. Now, what's happening is when you take the square root, right, you should always have I'm sorry, this should have been just x here. When you take a square root, make sure there's always two answers, okay? So go back and add plus or minus. Okay, so square root of 4 is going to be plus or minus 2. And square root of a -1 is always what? I. So we will put all of these together in one location. So the complex solutions are 7/3. That's one real solution. And there are two imaginaries. They are plus 2i and -2i. And guess what? This is the end of our video. Okay, so just a reminder, if you didn't get it, please do listen to it again.